When building arguments for quantified statements, we need to use the rules of inference for propositions, but first we must instantiate any quantified statement. Let's look at an example. Show that the premises, a student in this class has not read the book, everyone in this class has passed the first exam, imply the conclusion, someone who passed the first exam has not read the book. First, we'll identify the propositional functions. Let C of x be x is in the class, B of x be x has read the book, and P of x be x has passed the first exam. Then the premises are, there exists an x where x is in the class, and x has not read the book, that is the negation of B of x. And there's a for all x. If x is in the class, then x passed the first exam. And these are both premises. And the conclusion then is there exists an x such that x has passed the class and not read the book, which is the negation of B of x. So that gives us our propositional functions, our two premises, and the conclusion. And the first step that we're going to do is to instantiate, and I don't know if I have enough room. I think I'm going to have to go to a new page. So we'll go to a new page in order to do our instantiation. So put our step, we put our reason. Step number 1, we'll start with one of our premises. There exists an x such that x is in the class and x has not read the book. And that's a premise. And remember, we can't do our rules of inference on generalized statements, so we need to instantiate this first. So using our rules of inference for quantified statements, we can instantiate, and this becomes C of, and then we'll choose some other letter just to indicate that it's any element in the domain set for that function. And B of A. So now we have the instantiated version of that generalized statement. And since we have, we need to write the rule. This is instantiate. And that was number 2. Line number 3. Since we have an and between both of these, we can say that both of these must be true. Therefore, C of A is true based on simplification. From number 2. Okay. Then we can do number 4 as our other premise for all x. If x is in the class, then x has passed the first exam. Reason, this is just a premise. Then we need to instantiate next. So when we instantiate that, this becomes C of A, then P of A. Once it's instantiated, now we can do things with it. And if we're trying to figure out what we can do with it, well, ultimately we're trying to get that P of A to be proven true. So if we look at, all right, how can I get P of A to be proven true, we can go back up and we can look at lines number 3 and line number 5 and say, oh, wait a second, from those two lines we can do modus ponens. So now that we have that, we also need to have the negation of B of A. We don't yet have that. However, we can. If we look back up at line number 2, if we use simplification there, we can say, okay, we also have the negation of B of A by simplification. From line 2. Number 8, well, now that we have P of A, we already have that above, and each one of these lines is combined with an and, therefore we have P of A and we have B of A. The negation of B of A. And that rule, or the reason, is conjunction from 6 and 7. Now this is essentially what we wanted to find. If we scroll back up, it's what we wanted to find in our conclusion. We wanted to find there exists a P of X and negation of B of X, or not B of X. We essentially have that here. We've got passed the exam and didn't read the book. So all we have to do from there is go, okay, well, that is a true statement, therefore some element there exists. So we have a there exists. We're going to reverse backwards from the instantiation and go back to the generalization here. So we go there exists in X such that P of X and not B of X. And this is generalization. And that's how we start with generalized statements, quantify them through, quantified general statements, and we instantiate them. Once we have them instantiated, then we can use rules of inference for propositions, deal with them, and then when we get to where we want to be at our final point, then we can go back and generalize them. And that concludes that example.